Section 2.5, non-homogeneous equations. All right, well, we know that if we have an equation with constant coefficients, that is non-homogeneous, to solve, we need y sub c and y sub p. And again, what did y sub c stand for? Y sub c is the solution to the complementary homogeneous equation. And we know everything there is to know about finding y sub c. We factor, we find our r values. If our r's are real, we get e to a power. If r's are complex, we get some sines and cosines. We know how to do that. The hard part, what we don't know yet, is finding y sub p. Y sub p is any solution, any particular solution, to the original equation. And that's really what we don't know how to do yet. We don't know how to find that y sub p. What we're going to do, we're going to use a method called the method of undetermined coefficients. Which is a very nice name, the method of undetermined coefficients. It sounds a heck of a lot better than guess and hope that it works. And in reality, that's what we're going to do. We're going to guess and we're going to hope that it works. The good news is, by making some guesses and making some mistakes, we will come up with some ideas where we will understand how to make good guesses, and we will almost always get the right answer the first time after a while, once we learn how to make good guesses. All right, so let's start with a differential equation. How about we had y double prime minus 4y prime plus 3y equals, I don't know, anybody have an idea what you want over there?
0.
Anything except 0. 2x. Okay, so we have a 2x over here. We need to make a guess at what we think the particular solution might be, and then see if we can make it work. Anybody got a guess? Well, I'll give you a hint. 2x is what kind of thing? It's linear, isn't it? So anybody got a good guess? Something linear. That would be a reasonable guess. Since this is linear, it would seem somewhat reasonable that our answer should be linear. So I'm going to take a guess that our answer, the particular solution, is a linear function. Then what I'm going to have to do, I'm going to have to take the derivative, I'm going to have to take the second derivative, I'm going to plug it in and see if I can make it work. All right, so what would the derivative be? A. And what would the second derivative be? 0. Okay, so I take these three things and I plug it in. I have 0, I like that, minus 4a plus 3 times ax plus b would have to equal 2x. Okay, so what I did is I took yp double prime and I plugged it in right there. That was 0, so that just went away. That was nice.
Oh.
I took this yp prime, and I plugged it in right there, so there's where I came up with the negative 4a. And then I took my original function, my original guess, ax plus b, plugged it in there, but I got to multiply it by 3, so I get 3ax plus b. All right, a little simplifying here. This is minus 4a plus 3ax plus 3b has to be 2x. Now what? Any thoughts? You equate the coefficients. And this is why this is called the method of undetermined coefficients. The answer should be a linear equation, but we don't know what the a and the b should be. We don't know what the coefficients are. Well, b is a constant, but close enough. Equate the coefficients. What do you mean by equate the coefficients? Sounds fancy?
Take coefficients, that's x, right?
Yeah.
And set equal to its right side.
That's exactly right. The x's on the left need to match the x's on the right. There's only one thing with an x on the left, but that has to match the thing with the x on the right, which tells me 3a has to be the number 2. What am I going to do with these things?
Set equal to 0, right?
Those are just numbers, aren't they? A and B are numbers, so these are just numbers. So the numbers on the left-hand side have to equal the numbers on the right-hand side, but there aren't any numbers over here, so it's 0. So notice what we get. We're having this happen an awful lot in this class recently. We get a system of equations. 2 equations with 2 variables. Fairly easy system of equations to solve. I would not use a matrix, but you could if you wanted to. A is 2/3. Take that, plug it in right there. That's going to give you negative 8/3 plus 3b is 0. Solve that equation, you get b is 8/9. All right, so there's your particular solution. The particular solution to that equation, or at least a particular solution, is 2/3 x plus 8/9.
So what would have happened if we had guessed wrong?
What would have happened if we guessed wrong? We'll do that in just a second, and we'll see what happens if you guess wrong. Good question. Other questions? Okay, so let's take that same equation, y double prime minus 4y plus y double prime minus 4y prime plus 3y. And let's pick a different function over here. How about 4 sine x? Well, if this is a sine function over here, then what's a reasonable guess for your y sub p? A sine function. So that would be what I would guess. I would guess y sub p is going to be a sine x. Take my derivative, take my second derivative. Y sub p prime is a cosine x. Y sub p double prime is negative a sine x. Again, I'm going to take all these 3 things, plug in for the second derivative, plug in for the first derivative, plug in for the original function. I have negative a sine x minus 4a cosine x plus 3a sine x equals 4 sine x. What am I equating this time? all the signs on the left have to be the same as the signs on the right, and the cosines on the left have to be the same as the cosines on the right. For sines, I would have a negative a and a 3a, so that's 2a equals 4, which would tell me a is 2. But then I have a problem. The cosines tell me negative 4a equals 0, which tells me a equals 0. Can a be the number 2 and a be the number 0? No, what's that tell you?
You guessed wrong.
You guessed wrong. That's what's going to happen when you guess wrong. You're going to solve your system of equations. It's going to look like everything's wonderful, and then you get down to the end, you're going to get a system of equations that either you can't solve, it has no solution, or you get a system like this where you get two different answers for the same letter. That can't happen.
How did you get 2a equals 4 again?
2a equals 4 came from the sine functions. So I added those two together. Negative a plus 3a gave me the 2a.
So how do you guess right?
So how do you guess right? That's an excellent question.
Cosine.
So you think it should just be a cosine x?
Maybe.
Maybe.
I want you to give us a right guess.
You want me to give you the right guess? Okay. So I'm going to ask you a different question. What can you tell me about sines and cosines when it comes to solving differential equations?
Imaginary.
They came from imaginary numbers, right? So this sign came from, you can think if you got an r equals,
4 plus or minus I.
well, the 4, you don't have to worry about the 4. This just came from an r equals plus or minus I. When you get an r equals plus or minus I, you don't get just a sine, you also get a cosine. Sine and cosine, when you're solving differential equations, always come in pairs because complex numbers always come in plus or minus. You always get two of them. So our guess wasn't, well, it is wrong, and what's wrong with it is our guess isn't complete. We should have had an a sine, and we also should have had a b cosine. Sines and cosines always come in pairs.
B cosine, because the a in the imaginary numbers, the a carries out.
Like C1 cosine.
So one of them was C1 and one of them was C2?
Okay, so that's what we're looking for? It's
Right.
not like the a plus bi.
Correct, that's not what we're looking for. Typically, the standard notation is when you're solving the complementary solution, when you're finding the complementary solution, you use little letters for y sub c. So usually we use C1 and C2 when we're finding y sub c, and the standard notation is when you're finding y sub p, you use capital letters A and B, just so you can keep them all apart. But
Even though you used a and b in the imaginary.
so one of them might have an imaginary piece to it. That's correct. Okay, so same exact question, but a better guess. So the correct guess is sines and cosines come in pairs. So the correct guess is y sub p should be a sine x plus b cosine x. And you can kind of see up here what the problem was. The problem really was we ended up with this cosine and we didn't have anything to match it with. And that was kind of the problem. That's kind of why that crashed. All right, so we got to go through the whole same process again, find the first derivative, find the second derivative, plug it all in, see what happens. Y sub p prime is a cosine x minus b sine x. Second derivative, y p double prime is minus a sine x minus b cosine x. Plug it all in. Minus a sine x minus b cosine x minus 4 times, my derivative was a cosine x minus b sine x, plus 3 times my original, a sine x plus b cosine x, equals 4 sine x. Kind of long, but not terribly difficult. What we need to do now is run these coefficients through, and then gather up all the things that have sines, gather up all the things that have cosines, and put them together. So a lot of algebra, not much calculus. Minus a sine x, minus b cosine x, minus 4a cosine x, plus 4b sine x, plus 3a sine x, plus 3b cosine x equals 4 sine x. Alright, so now we put together all the things that have sine. There's something with sine. There's something with sine. And there's something with sine. And I'm going to go ahead and combine my like terms. I see I have a negative a and a positive 3, so that's going to be a 2a. And then I have a 4b. So my equation is going to become 2a plus 4b has to be 4. Good so far?
Why isn't it minus 4b?
Because this one with the sign had a plus 4b.
Okay.
Plus right there. Now I gather up all the cosines. There's one, there's one, and there's one. And again, I'm going to combine any like terms I have. I only come with an a, so that's a minus 4a. The b's, I have a 3b and a negative b, so that's a plus 2b. Equals, how many cosines are on the right? None of them, 0. Say that again. We're good? Well, once again, we end up with a system of equations we have to solve. You can pick your favorite way to solve it. Anybody got a favorite way? Matrix. Yeah, you guys love your matrices. I don't. I'm going to multiply that one by 2. 4a plus 8b equals 8. Negative 4a plus 2b is 0. Add them together. 10b is 8. So b is 8/10, which is the same as 4/5. I take the 4/5, I plug it into one of the two equations. It doesn't matter which one. I guess I'll use that one. Minus 4a plus 8/5 is 0. Minus 4a is minus 8/5. Divide a is 2/5. Oops, can't see. Did you get the same answer? Yeah, you get the same answer when you did the matrix? Okay, good. That means I didn't make any mistakes. Final solution.
Wait, should we be 4/5?
4/5?
But over there it's 8/5.
But then you have to divide by 4.
Oh, yeah.
2/5.
Yeah, where's the 8?
Where's the 8/5? Well, here was 8/5. I subtracted 8/5 on both sides.
Where does that come from? It's 2. Oh, okay, right.
That came from, yeah, I plugged in 4/5. 2 times 4/5 gave me 8/5. Y sub p is 2/5 sine x plus 4/5 cosine x. There's the particular solution. Questions on that?
You want to get
What's that?
as C. You want to you don't want to find C2, C1.
Oh, so your question is,
Because you have 10
Well, it depends on what the original question was. If the original question was find y sub p, then I'm done. If the original question was find the general solution to this equation, then you're right, I'm not done. I would have to find y sub c, and then I would have to take my y sub c and add it to y sub p. So my question was just find y sub p. So I'm all done. I don't want to make life harder for me.
That equation had equal, instead of 4 sine x, if it was 4 cos x, it would be the same.
If this started as a 4 cosine x,
Right.
your original guess would be exactly the same. It would have to have a sine and a cosine in it. Sine and cosine always come in pairs. So,
Why don't we put the e to the ax part of that?
what e to the ax part?
Because when you normally would do it, you'd have that e to the a plus bix. So why don't we incorporate the a?
Because this was just sine x,
Uh,
what that told me was that my r value was 0 plus or minus I. So e to the a is e to the 0, which is
1.
1.
So the e would show up in there.
Then you would need the e. That's right. Absolutely. We'll get to that. All right. What if you have y double prime minus 4y prime plus 3y equaled 7 e to the 3x. Well, if you have something that has an e to the 3x in it, what's a reasonable guess for your particular solution?
A, B, to the x.
And b is going to be the number 3. A reasonable guess would be y sub p is a e to the 3x. Take your derivative. Y sub p prime is 3a e to the 3x. Yp double prime is 9a e to the 3x. Plug it all in. 9a e to the 3x minus 12a e to the 3x plus 3a e to the 3x equals 7e to the 3x. And then we have a problem. What's the problem?
6, yeah.
You get 0 equals 7e to the 3x. When does 0 equal 7e to the 3x? Never. So what's that tell you?
Yes, wrong.
We made a bad guess.
You let us stray.
I'd led you astray again on purpose. You're absolutely right. I did lead you astray. What's wrong with our guess this time?
It could be a double root, so it could be a
No B.
Well, there was no b, that's true, but we shouldn't need a b.
was it a repeated root that we didn't
Should it be a negative?
No, shouldn't be a negative 3, shouldn't be a repeated root. What does it mean to take this and plug it in and end up getting 0? It's this answer that we picked happens to be an answer to the complementary homogeneous equation. Because, just for a second, let's solve the complementary homogeneous equation. This would be r squared minus 4r plus 3 equals 0. R minus 1 and r minus 3. So the complementary solution would be c1 e to the x plus C2 e to the 3x. So if I had used any number except for the number 1 or the number 3 right here, our guess would have been correct and it would have worked out. It would have been pretty simple. But I did it on purpose. I made this to be the number 3 to make it crash on purpose. I know you didn't want to pick 3. I made you pick 3. I kept pointing at it. Convinced you that that was the right number. Power of persuasion. Okay. So the issue is, this solution that we picked, this a e to the 3x, is not linearly independent with this solution that shows up in the complementary. So we need to pick something that looks kind of like e to the 3x, but is no longer linearly dependent. X e to the 3x. Okay, so the moral of the story is, you do need to pay attention to your complementary solution. Probably what we should have done right back from the beginning is found the complementary solution first. And then whatever you guess, you need to make sure your guess is always linearly independent from your complementary solution. Nope. Close. Ax e to the 3x. The power stays the same. To get it to be linearly independent, that was our trick before, we multiplied by an x. That's what we have to do here too.
Is that the only time it will ever come out to 0?
Yes. The only time it will ever come out to 0 is when the function you guessed happens to be a solution to the complementary.
Sometimes we'll be smart just to solve complementary really quick, just to straight up.
Every time you would be smart to solve the complementary quickly. Always solve the complementary first to make sure you're going to stay linearly independent from your particular. Well, this one's bad enough. I mean, think about what we're going to have here. Y double prime minus 4y prime plus 3y equals 7e to the 3x. Our guess needs to be ax e to the 3x. And putting that little x in there is going to make life a whole lot harder. How come? Because when I go to take the first derivative, I need to use the product rule. When I go to take the second derivative, I'm going to need the product rule again. Makes it a lot harder. But that's what it is, and that's what's going to work. It's got to live with it. Y p prime is...
So it is kind of like a repeated root, and then just simply add an x to it.
Exactly. You treat it like you have a repeated root. You add an x to it. Well, multiply an x to it, actually. But not add it. Multiply. All right. So derivative is, I leave the first one alone. That's ax. I take the derivative of the second one. That's 3e to the 3x. Plus, I take the derivative of the first one. That's a. And I leave the second one alone. That's e to the 3x. So I'm going to rewrite that as 3ax e to the 3x plus a e to the 3x. So there's the first derivative. Not so bad. I made it sound a lot worse than it really is. Second derivative. Again, right here, unfortunately, I need to use the product rule. I leave the first one alone. That's 3ax. Take the derivative of the second one. That's 3e to the 3x. Plus, I take the derivative of the first one. That's 3a. Leave the second one alone. That's e to the 3x. Plus, I don't need product rule here. I take the derivative. I have 3a e to the 3x. I'm going to combine up my like terms. I have 9ax e to the 3x plus 6a e to the 3x. I take my second derivative, I plug it in. My first derivative, I plug it in. My original function, I plug it in. And then I start equating coefficients. All that combined is going to be 9ax e to the 3x plus 6a e to the 3x minus 4 times the derivative, 3ax, e to the 3x plus a e to the 3x plus 3 times my original function. That's 3ax e to the 3x equals 7e to the 3x. Looks gruesome, but something really nice happens. Things drop out. Notice what you have. Notice the AXs. You've got 9AX, minus 12AX, and 3AX. What happens to all the AXs? They drop out, and that's what should happen. If you've done it right, all the AX pieces should add up to 0. They should drop out. And so we're left with 6a minus 4a. 6a minus 4a is 2a, and 2a has to equal?
So they have to distribute the 4 first? You have to distribute the negative 4 to all your...
Yep, because I'm saying I have 6a minus 4a, which is 2a, has to equal 7. So 2a has to equal 7, so a is 7/2. Okay, so again, you can check it. I skipped a lot of steps there, but you can check it. When you distribute and combine your like terms, those 3 add up to 0, they go away. So you're left with a 6a with an e and a minus 4a with an e, that's a 2a. Particular solution, y sub p, is 7/2 e to the 3x with an x here too. 7/2 x e to the 3x. Questions on that? All right, well, here's the good news. For the complicated questions, I'm not actually going to ask you to solve them. For example, if I was in a excited mood, let's say I gave you y double prime minus 4y prime plus 3y equals x cubed plus 4 cosine x plus e to the 8x. No. Well, the directions here would be set up the form of the complementary solution, but don't actually find all the coefficients. So all you're going to do is you're going to write y sub p is, all right, so what do you need for this x cubed?
A plus ax plus b.
No, we needed that when we had a linear thing there.
Ax cubed was plus
Bx
squared.
Ax cubed plus b, and then bx squared plus...
All right, so since we have a cubic here, our particular solution is going to have a cubic. So we write down a cubic. Since we have a cosine here, we're going to need a sine and a cosine. So that's going to be plus e cosine x plus f sine x. And since we have an e to the 8x here, we're going to need a
X e to G.
I don't need the x.
Oh, because it's not a solution.
What were the complementary solutions? E to the x and e to the 3x. Is e to the 8x?
Oh, yeah.
It's already linearly independent, isn't it? So you don't need the x in this case because e to the 8x is linearly independent from the 2 solutions you got from the complementary.
So that's extra credit to solve, right?
I feel like that's the same thing that what I was saying earlier. When I asked if we could have used 4x instead of 3x, you said no, but now we're using it.
Okay, so notice the difference. This one I put a 3x right there. And so your answer had to have a 3x in it.
Oh,
If I had started with a 4x here, then you're right, I would have put a 4x there, and I would have been fine. It would have worked out the first time. Because e to the 4x would not be linearly dependent with the e to the x and the e to the 3x. So your power here is always going to match your power there. And so this time, since I used an 8x here, I get to use an 8x there because it doesn't conflict with the answers I get from over here. 1, 2, 3, 4, 5, 6, 7. Wouldn't it be fun if I make you solve that? 7 equations with 7 variables?
That'd be very fun.
That'd be lots of fun. Oh, I'm glad you agree. I'm not going to make you do it, but I'm glad you agree with it would be. That's it. The directions will be set up the form of the solution. So there it is. All right, so let me give you another one. Y double prime minus 4y prime plus 3y equals x e to the 5x. Oh, heck, that's enough.
Wow.
Well,
Squared e to the a x squared e to the 5x.
I don't think you need an x squared.
Probably define x over 5. Should we find y sub c?
Okay, so I want you to think about this for a minute. Okay, we should find y sub c, but we already know what it is.
Oh yeah.
Y sub c is c1 e to the x plus c2 e to the 3x. So we've got an x and a 3x. This is a 5x. Everything's linearly independent. We're okay.
You're going to need an ax plus b, right?
An ax plus b?
For the x that's in front of the e.
If that were x plus e to the 5x, then I would need an ax plus b and I would need a e to the 5x. I want you to think about back when we were solving homogeneous equations. When did you end up with an x e to the 5x? That had to come from a repeated root, which meant you also had an e to the 5x, didn't you?
Right.
So this is coming from a repeated root. So I need an a e to the 5x
Plus bx
plus bx e to the 5x. You have to consider that x e to the 5x comes from a repeated root. So you need the original root and you need the repeat. So that's why that one was enough. That one was hard enough just with that because we had to remember. So you remember back when we did that, when I gave you the answer and said, now tell me what the equation had to be? That's why I was doing it. It set you up for this. You recognize that this comes from a repeated root, so you need the original and the repeat. Questions on that?
Yeah, what if that was an e to the 3x?
Wonderful question. I was hoping somebody would ask that. What if I ended up with that? What if I started with that differential equation? Y double prime minus 4y prime plus 3y equals x e to the 3x. Your initial thought should be that y sub p is a e to the 3x plus bx e to the 3x. That's what you would guess first. Then you would say, crap. It's not linearly independent because I already have an e to the 3x. So I need to fix it and make this one linearly independent.
You put x and then that's
So you multiply it by an x, but as soon as I multiply it by an x, it's no longer linearly independent too.
so then you multiply that one by
So you multiply that one by an x. So what you would have to do in that case is multiply both of those by an x to make everything linearly independent. Questions on that?
So you're giving us all of the like standard guesses that we're going to need?
Correct. All right, one more. Y double prime minus 4y prime plus 3y equals, I don't know.
Okay, no, it's
X e to the x cosine 5x. So this goes back to what Seth was asking before. How come there's not an E thing in front of it? There it is. I put one for you. Okay, so split this up. What does this e to the x cosine 5x tell you?
1 plus or minus I.
It came from complex solutions, so you need the sine and the cosine. But then what does this x out front tell you? It came from a repeated. So not only are you going to need the e to the x cosine and the e to the x sine, you're also going to need a repeated imaginary. So your y sub p, you've got to have an a e to the x cosine 5x and a b e to the x sine 5x, because sine and cosine always come in pairs. And then we need to deal with the repeated. So this is just the original root. Now we need to throw in the repeated, which means we need a cx e to the x cosine 5x and a dx e to the x sine 5x.
Leave it alone.
Imagine how exciting it would be to take the first and second derivative of that thing and that thing with those three terms and try to plug all that in. All right, so once again, this is what your homework's going to look like for quite a few of the problems, is set up what the solution would look like. And that would be your final answer. That's what your y sub p has to look like.